On April 2, 2010, a catastrophic explosion rocked a refinery in Washington. A ruptured heat exchanger in the Naphtha Hydrotreater Unit, NHT, released highly flammable hydrogen and naphtha at over 500 degrees Fahrenheit, causing a massive explosion and fire. Tragically, 7 workers were fatally injured. The incident caused over $39 million in damages and is one of the deadliest refinery disasters in the history. What happened? On March 28, 2010, the A/B/C heat exchanger bank was taken offline for cleaning, while the D/E/F bank continued operating. Cleaning was part of routine maintenance to remove fouling that reduced efficiency. On April 1, workers began restarting the A/B/C exchangers. These startups were considered hazardous and non-routine, with a history of leaks and fires. On April 2, early morning, during the final stages of startup, workers manually adjusted valves to regulate the flow of hot naphtha and hydrogen. At 12:30 a.m., the heat exchanger in the D/E/F bank catastrophically ruptured due to severe high-temperature hydrogen attack, HTJ, releasing flammable gases that ignited. The resulting explosion and fire burned for over 3 hours, causing fatal injuries to 7 workers near the heat exchanger. What are the root causes? High-temperature hydrogen attack, HTJ. The carbon steel used in the heat exchanger was severely weakened by HTJ, leading to fissures and cracking. Inadequate safeguards, the heat exchanger lacked inherently safer materials like high-chromium steel, which is more resistant to HTJ. Inspection failures, existing inspection techniques were unreliable for detecting HTJ damage, and Tesoro did not measure actual operating conditions, relying instead on design specifications. Normalization of deviance, frequent leaks and fires during previous startups were treated as routine, with no effective measures taken to address the underlying hazards. Ineffective process hazard analysis, PHAs failed to identify and mitigate HTJ risks, and workers were not adequately trained for non-routine operations like heat exchanger startups. Key lessons and recommendations. Upgrade materials, replace carbon steel equipment with inherently safer materials resistant to HTJ. Improve inspections, use advanced techniques to detect early signs of HTJ damage and validate actual operating conditions. Enhance process safety, implement robust process hazard analyses for all hazardous tasks, including startups, and limit worker exposure during such operations. Adopt inherently safer design, incorporate design changes to eliminate or reduce reliance on hazardous processes. Regulatory changes, strengthen industry standards, such as API RP 941, to require safer materials and enforce minimum safety requirements. Thank you for watching.